friends, in this video we are going to solve a problem on how we can find out the state space representation of a system. So let's take a problem. So our problem is to find the state space representation or the state equations of this system. Okay, and we have to choose the state variables as V1t and V2t. So these are the two state variables, and using these two state variables we have to find out the state equations and the state model of the system. So let's solve this problem. First of all, we will write the equations for this system. So using Kirchhoff's voltage law, we will write the equations for this system. So using KVL, the first equation for this system is, we have here V2t, the voltage at this node. So V2t minus ut upon R1 is the current flowing through this. So we will have V2t minus ut upon R1. Then for this capacitor C1, we have the voltage across this, or the current across this will be C1 dV2t by dt. So plus C1 dV2t by dt. Then for this resistance R2, we have V2t minus V1t upon R2. First we are writing the KVL at this node. So we will have V2t minus V1t upon R2 equals to 0. So this is our first equation. Now also at this node we will write the KVL. We will apply the KVL here and write the equations. So our equation will be, and also we will have C2 dV1t by dt, the current across the capacitor C2, plus V1t minus V2t upon R2 equals to 0. How we have written this? For at this node, the voltage across this capacitor will be, or the current will be C2 multiplied with dV1t by dt, we have written here, plus the current across this resistance will be V1t, because we are writing the node equation for this node. So we will consider the current in this direction. So it will be V1t minus V2t upon R2 equals to 0. And also we have this V0t, it will be equals to V1t. Now rearranging, we have two equations. First is this equation and second is this equation. So rearranging, we will get so what we have done, we want to get the value of this dV2 by dt. So from here dV2 by dt will be This will goes to the right hand side and this term will also goes to the right hand side divided by C1. Then we have put this value here. From here we have taken the value of V1, this dV1 by dt, and we have substituted here in this equation. So we have got the value of dV2 by dt, or we can write it as V2 dot in terms of the two state variables, because we have to choose V1t and V2t as our two state variables. So this equation is the derivative of the state variable V2. So this will be equals to V1t 1 upon C1 R2 Okay, so this is the equation for V2 dot, or the derivative of the state variable. Now here from this second equation we can get the derivative of the state variable V1. So its value will be this will goes to the right hand side. So it will become minus V1t upon R2C2. This C2 will goes in the denominator. Then this will become plus V2t upon C2 R2. Okay. Mark this equation as third equation, and when we solve this equation we will get our V1 dot, that is the derivative of the state variable V1, and it will be equals to V1t 1 upon, from here it will be V1t multiplied with minus 1 upon R2C2 plus V2t multiplied with 1 upon R2C2. Mark this equation as fourth equation. So you can see that this third and the fourth equation, they are the derivatives of the two state variables V1 and V2. So using these two equations we can find out the state equation of the system. So how it can be written? We have V1 dot, V2 dot. It will be equals to our two state variables are V1 and V2 plus we have ut. So for V1 dot the equation is this. So the coefficient of V1t will be minus 1 upon R2C2. So we will write here minus 1 upon R2C2. The coefficient of V2 is 1 upon R2C2. So we can write 1 upon R2C2 here. Then from the third equation for V2 dot we have V1t as coefficient of V1t is 1 upon C1 R2. So we will write 1 upon C1 R2. Then the coefficient of V2t is minus, this is minus sign. So the coefficient of V2t, it is minus sign, and 1 upon C1 R1 plus 1 upon C1 R2. So we will write this here minus 1 upon C1 R1 plus 1 upon C1 R2. Then the coefficient of ut is 1 upon C1 R1. In V1 dot ut was not present, so we will write 0 here, and here the coefficient is 1 upon C1 R1. So this is our state equation. State equation because it is defining the derivatives of the state variables as a linear combination of the state variables and the input. So it is defining the state variable, so it is called the state equation. Now we also know that the output is our V0 t. So in this diagram you can see that V0 t is equals to V1 t. So we have another equation, V0 t equals to V1 t. This is our fifth equation. So from this equation we can write the output equation. So output is what? V0 t The two state variables are V1 and V2. So V1 is coefficient is 1, so we will write 1 here, and V2 is not present, so we will write 0 here. So this is our output equation. So these two equations, state equation and the output equation, they constitute the state model of the system, or we can say that it is the state space representation of the system. So in this way we can find out the state space representation for any type of system. We will write the equations for the state variables, derivatives of the state variable and the output variable. So I hope this problem is clear to you. Thank you.